Question 8 is a simple linear programming question. We're just going to pretend that those inequality symbols are equal signs and graph them, and work out which side of the line we should shade. And then for Roman numeral part 2, we're going to do a sample grays line. So for example, I'm going to say x plus 2y equals 10. I'm going to graph that, and then I'm going to bring that grays line down until it touches the region, and that will enable me to identify the point which leads to the highest value of x plus 2y. So let's start this. Here's my graphing of that. X and y are on the same side, so that's, graph that. So that's a classic example of a quick table. If x equals 0, then y equals 9. If y equals 0, then x equals 6. You have to make your own call about how precise you want to be on these things. Because the grays point is determined by how steep things are, I tend to be very careful in graphing these linear programming ones. So that genuinely is 6 centimeters, that genuinely is 9 centimeters. What others do we have? Y equals 3x. Well, that's just a 45-degree line made 3 times steeper. So it would normally go through there, there, and there. I'm making it go through could also use a table of values for this. I'm just doing it by transformation, making the points 3 times higher. Being bad here, I normally remember to do dotted lines so that I can fill them in later. In fact, this will be a waste of time if it later turns out I have to fill in these lines. Which I don't think it will actually, because we've got not just these symbols, but those little bars there. And then finally, y is greater than 0, so that's this. Now, you want to save time, you can usually just shade in this enclosed region, but let's be careful about this. We want the region where y is greater than 0, so we want this side of that line, so we shade down here. We want the points where y is less than 3x, so we want, that's confusing me, so I'm going to do a test point. What's a point that's clearly not on the line? So 5, 0. So 0, 5. Does that make this true? That is not true. 5 is not less than 0. So we do not want that, so therefore we shade it. And I'll do this point, one by test point as well. Let's try 0, 0. Is 3 times 0 plus 2 times 0 less than 18? Yes, it is. So we do want this side, so therefore we don't want that side. We do want the lines, therefore they're dotted, and that is Roman numeral part 1. Number Gray's line, x plus 2y equals, what did I say I'd make it? Let's say I'll make it 10. So, quick table for that. If y equals 0, then x equals 10. If x equals 0, then y equals 5. So there's my 10 out there. So this fella here is my Gray's line, which I'll do in a different colour actually. Now, imagine that coming down from over there. It would hit to here. So this is the graze point. What's the coordinates of that? Do that by simultaneous equations. So y equals 3x on the one hand and 3x plus 2y equals 18 on the other. Well, that's a gift. Look, they've told you what 3x is. So where there's a 3x, don't write a 3x, write a y because that's what it's equal to. So y, wait on, 18, so therefore y equals 6 and x equals 2. So now just substitute that into the thing you have to maximize. What did I have to maximize? It was x plus 2y is at a max when x equals 2 and y equals 6. In other words, just the coordinates of the graze point. So the answer to that is 14, I hope. Yeah, that's the answer to that. So that's question number 8.